So this part is like the I'll say the central theme of physiology. We remember we talked about homeostasis at the beginning of the semester, which is, I should say, this should be in the first lecture. First lecture in this semester. We also end this semester with homeostasis because physiology that you will take, if you take physiology, you will see homeostasis as the main theme in different organ systems. So again, as a review, homeostasis is the maintenance of the relatively constant internal environment by an organism or even by a single cell. Our body tries to maintain a constant environment inside our body so that all the chemical reaction can occur. And another reason to that is because the external environment changes all the time. Well, you can imagine the temperature, the surrounding temperature. In daytime, around noontime, it can be very hot, but in morning and in the nighttime, the external temperature of our environment can drop really quickly. So it is important to maintain our internal environment, let's say, at a relatively constant 37 degrees Celsius. This is what we call the homeostasis. But homeostasis doesn't mean that, okay, it is constant at one level. We call it dynamic equilibrium because our internal environment, they also fluctuate, they also change. But even when they change, they are fluctuating above and below at a certain value. So they change, but the change is relatively minor, and the average is actually at the same level. For example, we said that our body temperature is at 37 degrees, but it actually fluctuates between or on top or below 37 degrees. How do we maintain homeostasis? How do we maintain a constant environment inside our body? We use something called a negative feedback. Negative feedback is the major mechanism to bring our body temperature back to the so-called set point, or bring our body temperature back to homeostasis. In negative feedback, we have minimum two components. Minimum. One is a sensor. Sensor usually is a receptor. A receptor that can detect changes in the environment. A receptor. For example, the temperature receptor on our skin can detect the temperature on outside of our body in the environment. And now control center. Control center, usually we talk about control center is our brain, our central nervous system. So when the sensor receptor detect the changes of the temperature outside our body, you will send the changes, you will send the signal or the action potential to our central nervous system, to our brain, so that our brain will analyze the information, and then you will send the output signal to tell our body to change in response to the changes of the outside environment, so that the changes in our body will help us to keep our body at a set point, or to maintain the homeostasis. An example here is the pancreas. Your pancreas in this case is not part of the central nervous system, it's not part of the brain, but pancreas can detect the blood glucose level. If your blood glucose level is high, then your pancreas will secrete insulin. Insulin is a hormone. In this case, pancreas acts like an endocrine gland. Pancreas acts like an endocrine gland. It can secrete a hormone called insulin that can cause a cell to absorb glucose into the cell. in this case, you will decrease the blood glucose level. When the blood glucose level decreases, then you will restore it to the normal set point. In this case, it is an example of homeostasis. Negative feedback is example of negative feedback to bring your blood glucose level back to homeostasis. So this is the scheme that we saw at the beginning of the semester. At first, your body is in homeostasis, then you may have too high of the blood glucose level. Your blood glucose level is too high. Why? After you finish eating a meal. After you finish eating a meal, then your blood glucose level becomes too high. Then what will happen? Then your pancreas, the stimulus, the high blood glucose level will trigger. Your pancreas is the sensor that can sense that you have too high of the blood glucose level. And then the control center in this case is also the same. Your endocrine system, your pancreas. The pancreas will secrete insulin. Your insulin will tell your body cell to absorb glucose from your bloodstream, so that glucose will go into your body cell, and the glucose in your body glucose in your blood will decrease, and then you will restore the homeostasis. And this is another example, is your regulating of your body temperature. The regulating of your body temperature is like a thermostat. So you set your thermostat at a certain temperature, so that when your thermostat detects the room temperature, let's say it's too hot, then the furnace will turn off. But if your room temperature is too cold, then your furnace will turn on, so that you will maintain your room temperature at a certain set point. In this case, we set it at 68 degrees Fahrenheit. In our body was set in a 98 degree Fahrenheit. So the furnace, the thermostat, the reaction of the thermostat to the changes of the room temperature is an example of negative feedback.